Streamline flow. Streamline, disciplined, channelized flow. Streamline flow. Streamline, disciplined, channelized flow is in accordance to the law of conservation of energy and kinetic energy per unit mass is always constant. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. This is my last session on the unit Mechanical Properties of Fluids, where here again I have formulated the concepts in terms of question and answers, most likely 1 markers and 2 markers, which will help you to perform better in the exam. And I told the entire chapter, the entire concept, fluid mechanics, is to understand the virtue of the flow of fluids. What are the necessary arguments, the necessary follow-ups when it comes to the motion of fluids? For example, difference between streamline and turbulent flow, equation of continuity, discussing the motion of fluids, Bernoulli's theorem expressing the motion of fluids, and finally the application of Bernoulli's theorem. And all these concepts coagulated, put together, is what we understand as fluid dynamics, or most likely called as fluid mechanics. Now students, the first question: what do you mean by streamline flow of a liquid? To define streamline flow of a liquid, if you recall back, the streamline flow was also called steady flow of liquids. It was also called orderly flow of liquids, or one more very important term, laminar flow, which again means regular flow of liquids. So it is steady flow of liquids, orderly flow of liquids, or what we also call the regular or laminar flow. A beautiful flow describing liquid motion. So as I told, we will consider a pipe, 3 different points of the pipe, A, B, C. As a liquid flows through this path, the first particle of the liquid enters the point A with velocity v1, moves to the point B with velocity v2, passes to the point C with velocity v3, and finally comes out of the pipe. Now, the second particle of the fluid enters the pipe with the same velocity v1 at the point A, velocity v2 at the point B, velocity v3 at the point C. And here, if the motion happens such that any particle of the liquid has the same velocity throughout its flow, such a flow is called streamline flow. Streamline, disciplined, channelized flow. So it is steady, it is regular, it is an orderly flow. The reason being, all the particles move in the fluid at any point with the same velocity. They are disciplined. They have the same velocity. And that is what is called streamline flow. The next one, very important question. Again, 1 mark. To define critical velocity. Critical velocity of a liquid in motion. It is the minimum velocity of a liquid. Minimum velocity of a liquid below which there is streamline flow, or I can say above this velocity called critical velocity, the streamline flow is broken up. The flow now becomes violent and it is called turbulent flow. Threshold velocity for liquid flow. Look at it, TV. So the minimum possible velocity for the flow of a liquid until and unless it can sustain streamline motion, turbulent motion is not into picture, is critical velocity. Only about this velocity called critical velocity, that disciplineness is broken down and the flow becomes turbulent. So now, what is meant by turbulent flow? Irregular, disorder, non-steady, where the particles of the liquid will possess different velocities at each point. Why? The critical velocity is broken down. At every single point at the path of the flow, each particle has different velocity, and that is what is called turbulent flow. The next question, students. What is Reynolds number and what are its dimensions? Reynolds number is a number that will characterize the flow of a liquid. It's a number. If the Reynolds number for a flow of liquid is less than 2000, we say it is streamline flow. When the Reynolds number is less than 2000, the flow of the liquid is characterized to be streamline, orderly. If it is greater than 2000, this is where critical velocity is broken down and the motion becomes turbulent. So, a number which actually defines the flow of a liquid is called Reynolds number. If it is less than 2000, it is streamline flow. If it is greater than 2000, it is turbulent flow, and it is a number. It doesn't have any unit. It is dimensionless. Purposefully, they asked this as a 1-mark question. Write the dimensions of Reynolds number. It's a number, scalar, dimensionless. So, Reynolds number is dimensionless in nature. The different forms of energy possessed by a liquid, Bernoulli's theorem applications allodidivi. A liquid can possess 3 forms of energy: either pressure energy, kinetic energy, or potential energy. So the 3 forms of energy possessed by a liquid is either pressure energy, kinetic energy, or potential energy. We have clearly understood this way back in our Bernoulli's theorem. Expression for total energy per unit mass, per unit volume for a liquid in motion. Come on, kids, recall back the statement of Bernoulli's theorem. For an non-viscous, incompressible fluid, non-viscous, incompressible, the so-called ideal fluid, the sum of its pressure energy, its potential energy, and kinetic energy per unit mass is always constant. So, total energy per unit mass, P by P plus half V square plus GH per unit mass per unit volume, P plus half rho V square plus rho GH. So this is rho density, rho GH. So this is per unit mass and this is per unit volume. We have written the mathematical expression for Bernoulli's theorem in terms of unit mass and unit volume. What is the basis on which Bernoulli's theorem is stated? Very, very important. For 1 mark again, they ask this very much. Bernoulli's theorem is based on the law of conservation of energy. So the statement of Bernoulli's theorem is in accordance to the law of conservation of energy, or Bernoulli's theorem signifies the law of conservation of energy. What is an venturimeter? It is a device which works on the principle of Bernoulli's theorem, or we say it is a gauge used to measure the rate of flow of fluids in steady motion. Bernoulli's theorem is applied for steady flow. So venturimeter is a device used to measure the rate of flow of fluids. Atomizers, sprayers, they are all used and works on the principle of Bernoulli's theorem. And very importantly, we also studied equation of continuity. What did it say? A1 V1 equals A2 V2 is always constant. The product of area of cross section of flow and velocity of a fluid across that cross section is always constant. And therefore, the volume of a fluid which enters the pipe should be equal to the volume of the fluid coming out of the pipe. Which means again, yes, equation of continuity staggers and defines steady state or what is called steady flow. So these are the question and answer forms from this chapter. My next session, I start up with a new chapter, new session, physical world. Until then, start preparing hard. It's time to ring the bells. Have a nice time. Thank you.